Hi everyone, in today's lesson we're going to extend our understanding of the gradient of the tangent to include not only finding the equation of the gradient of the tangent, but also finding the gradient and the equation for the normal to the curve. Now, if you think back to our previous lesson, we found that we could find the equation of the tangent, so our black line here, at any point once we knew the gradient and using the point gradient formula. Now, we also know that a normal is a straight line that is perpendicular to a line, or in this case, the tangent. So our red line here shows us what our normal to the equation, normal to the curve would be at that point. And normal means we have an angle of 90 degrees. So this means that to find the gradient of the normal, what we can do is we can find the gradient of the tangent, and then we can use our formula for perpendicular lines to find the gradient of the normal. Because the two gradients, the gradient of the tangent and the gradient of the normal, when we multiply them together, the product will be -1. So let's look at an example to help explain what we mean by finding the equation of the normal. So the first thing we're going to do is we're going to find the gradient of the normal for this curve at the point 2, 5. So we have our curve, which is y is equal to x cubed minus 2x squared plus 5. And we are looking at finding the gradient of the normal at the point 2, 5. So we have our point here, and we are looking for the gradient of the normal. So there's our tangent, and we are looking for the gradient of this line here, which would be 90 degrees to that tangent. So the first thing we need to do is, just like we've done previously, is we have our original equation. And we are going to differentiate that to find the function for the gradient of the tangent. So we have got 3x squared minus 4x as our function for our gradient of the tangent. And at x is equal to 2, then our gradient, dy dx, is going to be equal to 3 times 2 squared minus 4 times 2. So we have 12 minus 8. So we have a gradient of 4. So our gradient of the tangent, m1, is going to be equal to 4, which means our gradient of the normal, m2, needs to be the figure that will give us of -1 as the product. So we know that 4 m2 is going to be equal to -1. So our gradient of the normal has to be -1/4. So now we know our gradient of the normal. And now we can use that gradient along with our point to find the equation of the normal, just like we found the equation of the tangent in the previous lesson. So using our point gradient formula, y minus y1 is going to be equal to m outside of x minus x1, which means we have y minus 5 is equal to -1/4 outside of x minus 2. So we have y minus 5 equals -1/4 x plus 1/2. So y is equal to -1/4 x plus 1/2. And as finding the gradient of the normal often has fractions as our gradient, a lot of the time we will show this in general form for the equation. So we're going to multiply everything by 4 to get rid of the fractions that we're dealing with here. So we'll have 4y is equal to minus x plus 2 And taking everything across to one side, we'll have x plus 4y minus 2 is equal to 0. And now we have found our equation for the normal. So now let's look at an example where we've got the x value, but we haven't been given our y value. So we're finding the curve, for the curve y is equal to minus x cubed plus 3x squared plus 2x minus 1. We want to find the equation of the normal when x is equal to 3. So we're looking for our purple line here as our normal. So we need to find the equation of this line. So what we need to start with is, if we know that we're looking for when x is equal to 3, then our y value is going to be negative 3 cubed plus 3 times 3 squared plus 2 times 3 minus 1, which means first two we're going to cancel out and we're going to be left with 6 minus 1, which is 5. So our point that we're looking at is 3, 5. And if we look at our graphic, at our sketch here, we can see that that makes sense there. We have that point of 3, 5. So now we're going to find our first derivative. So we're going to differentiate y in order to find our gradient of the tangent. So we have got y is equal to minus x cubed plus 3x squared plus 2x minus 1. So dy dx using our power rule is going to be negative 3x squared plus 6x plus 2. And when x is equal to 3, we'll have negative 3 times 3 squared plus 6 times 3 plus 2. So we'll have negative 27 plus 18 plus 2, and we'll get negative 7 as our gradient. And if we look at our blue line over here, we can see that, yes, that line does look like it's got quite a steep slope going in the negative direction. So a gradient of negative 7 there makes sense. So now that we know our gradient of the tangent, we can now use our perpendicular lines gradient formula to find our gradient of the normal. So we have negative 7 m2 is equal to negative 1. So taking that across, m2 is equal to 1/7. So now we have our point and we have our gradient of the normal. So using our point gradient formula, y minus 5 is equal to 1/7 x minus 3. And before expanding the bracket out this time, we know we're going to get rid of the fraction at the end and leave it in general form. So I'm going to get rid of that fraction before we do the expansion. So we're going to multiply everything by 7 to remove that fraction. So we'll have 7y minus 35 is equal to 1 outside of x minus 3, which means we can just remove those brackets straight away. So 7y minus 35 is equal to x minus 3. And now if we move everything to one side, we will have 0 is equal to x minus 7y plus 32. So now we have our equation of the tangent. Now we have our equation of the normal. Now when using equations of the tangent and equations of the normal, we'll find that we can make some geometric shapes based on what happens on the Cartesian plane when we're using these equations. So in our last example, we're going to look at what happens when a shape is created by the equation of the tangent and equation of the normal, and then find the area of that shape. So we're going to examine the curve y is equal to x squared over 2 plus 3, which you can see in our graph down there. And the first thing we're going to do is we're going to find the equation of the tangent at the point 2, 5. So we're looking here at this point 2, 5. So we are going to find the equation of tangent, which will run through somewhere like that. So as we've done previously, we know the point, so all we need to do is find our derivative. So we know y is equal to x squared over 2 plus 3. So dy dx using our power rule is going to be 2 times x over 2 plus 0. Our 2's cancel out, and we're left with just x. So dy dx is equal to x. So at x equals 2, dy dx is equal to 2. So we now know our gradient for our tangent. So using the point gradient formula, y minus 5 is equal to 2 outside of x minus 2. Expanding out, y minus 5 is equal to 2x minus 4. So y is equal to 2x plus 1. So now we have our equation of the tangent, and we can see that our original line drawn there was off slightly, so we'll just now readjust that. So we'll get rid of the line that we had there. We now know that our line passes through 1 here, so we can straighten our tangent up to suit. So now we have our equation of the tangent. So now we're going to be looking for our equation of the normal, which is going to be a line that's going to pass through something like that there. So we have a right angle in this position. So let's find out what that position will be. So what we're starting with is we know that if the gradient of the tangent m1 is equal to 2, then multiplying our two gradients together will give us -1 as their perpendicular. So we have 2 times m2 equals -1. So m2 equals -1/2. So y minus 5 is going to be equal to -1/2 x minus 2. Expanding out, y minus 5 is equal to -x over 2 plus 1. So y equals -x over 2 plus 6. Now the reason why I've left it in gradient intercept form is we now know our intercept here is 6. So we can draw our line in, and you can see we've created a right angle triangle between our points here. So we have point A, point B, and point C as shown there. So that answers our other questions there. So all we're left with now is finding the area of the triangle ABC. So we can see that triangle ABC, we have a base here of our y distance. So our base there, so area of a triangle is half base times height. So we have a half times our base, which is going to be 6 minus 1 for our distance along the y-axis. And then we're going to times that by our height, which is our distance along the x-axis. And we're going to have 2 minus 0. So we've got half times 5 times 2, which means our area is going to be 5 units squared.